So okay, so let's do some more applied coding sessions here on this on the nk.mod, right? And what I have here is our little notepad, and so I like to think about this as this. We just finished the task number 1 in familiarizing ourselves with this nk.mod. Okay? And I want to do two further tasks on you with this. So the task number 2 is the following. Task number 2 is simulate this model and simulate artificial data from this model to monetary policy shocks only. So simulate artificial data for output and inflation in this model for long periods of time to monetary policy shocks only, and produce a scatter plot of inflation versus the output gap. So let's write this down. So simulate data, simulate a sample of artificial data, model data for 1,000 periods, for 1,000 quarters, to monetary policy shocks only. Monetary policy shocks only. So I want us to simulate this model for 1,000 periods and produce a long simulation to monetary policy shocks only. And then I want us to plot the time series, plot the time series for inflation and the output gap. Right? So I want to just have this, plot the inflation time series, plot the output gap time series. Then I want us to produce a scatter plot and to compute the correlation between pi and x. So I want to basically have us doing the produce a scatter plot of this model to monetary policy shocks only, related to the things we discussed on Wednesday. And I want to teach you, I want to explore with you how can we produce all these things in Dynamo. And in the end, it will come to you as a surprise, but this is going to be 5 lines of code. So we will be coding that in 5 lines. So it's not a major effort. So we don't need to write hundreds of lines of code to do that. But I want to teach you how you can produce this and how it relates to the things we discussed on Wednesday. Any questions? So let me maybe highlight what are the important things. So we want to have simulate this for 1,000 quarters to policy shocks only. That's the first thing. Okay. And then we want to plot these time series. So let's figure this out together. Okay. So the first idea is follows. We only want the monetary policy shocks. So let's go into this into our live coding code and be aware that this model so far has 2 shocks, right? It has the monetary policy shock, but it also has the technology shock. And we want only one. That is, we want to switch off this shock. We want to switch off the technology shock. So what we want is we want to set the variance of the technology shock to 0. So that when technology shocks don't move. Right? That's the idea. And so the first step to do is we have to go to the parameters and we have to find the place in line 40 to switch off and set 6z equal to 0. Because when you set, and the way I always do this, I write my new number, 0, I write semicolon, and then I write 2 forward slashes. In this way, I keep the original number that I can go back to if I want to later on. Okay. So we literally just set the variance of technology shocks to 0, so the only shocks that are going to be active and alive, and when we simulate this for long periods of time, it's going to be the monetary policy shock. All right. So maybe we can do an annotation, we want to set, technology shocks to 0 for all periods, and only have the multi-quality shock. Great. So that was the first step. Second step, now what we do is we go downstairs and we have to now work with this stock simul command. Okay. Jesus, my dear, sorry, you shouldn't see that because we're going to do that together. So to simulate the model, Dynere gives us the simulation. Okay. And what Dynere essentially does, let me share my screen here. What Dynere does it takes this solution, and this is not for technology, but you have the picture, this is for the multi-quality shock, and then draws a sample for 10,000 periods of the shock, and then simulates inflation using this recursive notebook, this solution, right? So you can think about technology is 1%, you're going to get inflation 2%, and so forth, and so it simulates this for long time series. That's what Dynere is doing in the end. And Dynere can be, gives you that by extending the stock simul command. And the holy grail command to do this is, you go here, you put comma, and then you do periods equal 1,000. So maybe you could do an annotation, you could, do these 2 forward slashes, and you could write, simulate data from the model for 1,000 periods. Okay? That's what this means. So it does not only produce impulse responses, but it also produces now artificial data of length 1,000. Now, in case you are struggling with, okay, Matthias, how do you know all this? Where does this all come from? And if I want to change stuff, how can I find this? Well, you can go on an AI, you can go to Cloud or ChatGPT, or you just go onto the web, and you're just typing in on the web, and maybe that's good for you, just type in Dynere manual. And then you hit enter, and then there is going to be a website, which is the Dynere website, the Dynere.org, this website, and you're just going to click on that manual, and if you are clicking that manual, this is how the Dynere manual looks like on the web. It's a website, and then you can get all the details on Dynere. You can go through this one by one, or you just type in here into the search button, type in stock _ simul, and then you hit enter. And when you hit enter, Dynere gives you all the hits associated with your search, and you just take the first stock simul there. You click on that stock simul button or link, and then it's going to take you to the syntax that you can use for stock simul. And then you'll see a description of what it does, and here are all the options that you can put into the parentheses of stock simul. Right? And we have been using, for instance, IRF equal 10. Right? This is an option in stock simul. Right? Like this option, IRF equal to 10. That's how you put this in terms of the stock simul. There's lots of options, and when you keep on scrolling down, here's there's the order option, and then here's the periods option. That's what I want to do. So here is your simulated data from the model, and this tells you also where you can find the simulated data. Maybe here. The simulated endogenous variables are made available to the user in a vector for each variable in the matrix OO _ endosimul. And we'll see where that is. So Dynere simulates this for them and gives us then the data that we can work with. So maybe you want to save that website on your bookmarks so that you can find this. You can also download this as an HTML file, by the way, or as a PDF file. I believe if you go back, let's see, there is, I think, a way to download this as a PDF. let's go, if you go to the Dynea website, here, I don't want the manual, I want the plain vanilla website. So this is the plain vanilla Dynea website, right? So this is www.dynea.org, and if you click on this documentation button here, well, they have changed that. Now they have changed it. This used to be a PDF file available as well, but this seems to be now only available as an HTML resource. Okay? Good. Perfect, guys. All right, so we have now simulated. Now let's do the following. Let's run this code and make sure everybody can run this code. Okay? So we're going to type in Dynea nk_livecoding.mod, and then we hit enter. And what should happen is that you're getting impulse responses. Okay? And the first thing to note is now we only get one impulse response figure. You get the impulse responses to the epsilon nu shock. You don't get a second figure because we have set the variance of that second shock to 0. And Dynea doesn't compute impulse responses to shocks with 0 variance because they are constant, they're not shocks. So who has that picture? Who has that one picture on your computer screens? Who has an error message? Somebody, okay, so let's see. Change that, and then did you upstairs? Can you see? Can you try to run it again? Let's see. But it did work before, right? You got the impulse responses before. Can you type in clear all? Seems to be like an X. So can you run it? You know what? Can you shut down MATLAB and restart MATLAB and try to shut down MATLAB and restart MATLAB? All right. So how are things looking here? Any also a problem? It looks good. I see, but so there's just it looks it's, yeah, but there's these are just warnings, right? So there's no yeah, these are just, red are just warnings. If you scroll up, I think it's something to do with the, yeah, okay, that's good. This is just warnings, you can ignore that for now. How about you? This is great. And here, this also is great. Okay. So let's see. Let's try that again. And I think you have everything controlled perfect. Let's see. So what I will be doing after class today, I will be uploading the live coding script that I have onto Moodle. Okay. So just for you to know that this NK live coding that I have up there is going to be available on Moodle after class. Let's see. Let's try to have Lynn be able to run this as well. problem here with your file access, which is really weird. I'm trying to run another file here. Linear and keyboard. Then there is a problem with, I don't know, even the standard NK.mod file doesn't run on your computer. Now, I tried the standard NK.mod file, and it produces the same mistake. There's somehow a problem with accessing the file system. I don't know what that is, frankly speaking, which is really weird. I think for now, to make progress, I think the best would be, let me just try one thing. We delete this, and then if that doesn't work, I would like to ask you to work with Ivy together on your computer. No, the original file doesn't work either. And there's a deeper issue here. Right? Yeah, you see, it's not this live coding file that has a bug. Also, the standard NK.mod file doesn't seem to run. It used to run before, but now it's not. So I think maybe could you work with Ivy together on Ivy's computer? And then, because this will take much longer to fix. This will take a long time to fix, I think. But you were able to run NK.mod before, right? Yeah, try to work with Lynn, and you guys share one computer so you can work together, okay? And then we will, you should try over the weekend to try to figure out why, this doesn't work any longer. It used to work, right? Okay. Anyways, good. All right. So we have. So now what we did already is the Diner simulated the model for 10,000 periods. Now we just need to peel out, find where is this stored. Where do we get this data? And then we have this data in a particular field in Diner, which is called OO. So small letter O underscore. Okay, this is a field or a structure in MATLAB or in Diner, right, that you can find in the workspace there that has all the things we want. Okay? So if you type in OO underscore and you hit enter, then you're going to see what's in this OO underscore field. Okay, so in the structure, right? So this structure contains many things. And what we want is, we want all the things that are in this part of the structure. Because in RedRC, Diner simulates the model, we simulated it for 1,000 periods, and we have 8 model variables, right? We have to find 8 variables, and so what this is a matrix where in the rows we have the variables, and in the columns we have the time. So that's the matrix we want to enter, we want to have access to. So let's take a look into this. The way how you can get access now to these fields is you're typing in OO underscore, and to access, say, the field we want, we have to put in a little dot. Okay? So OO underscore dot, and then you write endo underscore simul. That is the matrix that we want, that has all the data that is simulated by the model. And if you hit now enter, you're going to see this is a matrix that has 1,000 columns, right? MATLAB prints all these 1,000 columns up, and there's a lot of entries there. You see, so it's 1,000 columns, and so this is the last period of the simulation. Okay, and then we have 8 rows: 1, 2, 3, 4, 5, 6, 7, 8, and these are the endogenous variables. Now you need to know what is the what's the ordering, right? So what is inflation here? Which line is inflation? Which line is the output gap? Which line is the interest rate? And the ordering is the following. The ordering is if you go to your bar statement, the ordering by which you have typed in these variables is the ordering of the rows in the matrix. So the first row in that matrix is inflation. The second row is the output gap. The third row is the interest rate. So that's what you have to be aware of. Right? The first row is the inflation simulated data. The second row is the output simulated data, and so forth. Okay. So now what we just do is we're just going to access this data in this matrix. Okay. And then we have done the first task of this exercise. So the way to write this is we're going to define a new variable in line 105 that we call infl sim for inflation simulated data. And that is equal to OO underscore dot endo underscore simul. Okay, so we're going to access that data. Now we open the parentheses, and now we say, okay, we know it's in the first line, right? So we're going to say 1, because that's the first row, comma, everything, give me all the columns. That's what the syntax here is. Okay? So this is a matrix, and we are accessing, so we get access to the first line, the first row of that matrix, and we want to have all the elements. Don't write that, please, but say, suppose you're only interested in the first 100 elements, then you would have something like this. Okay. So 1:100 is, you only have access to the first, you only want to have the first 100 elements. Or, don't write it please, if you are interested to have the elements from period 111 to 112, then this is the syntax for it. And colon means you want to have all. So let's write this. Extract inflation simulated model data from endo simul. Okay. So that's the idea. Now we have the inflation data. And if we go back to the task that we're supposed to do, and I ask you in the task, now we're supposed to plot it, right? But before we do that, why don't we do the following, folks? It's always good to minimize mistakes. Why don't we just run this code? Okay. So let's run this code. Let's just run this mod file and see what it does. And if things go well, you get this one picture, and you shouldn't get an error message. That sounds like an error message. So let's run your code and let's see whether you have an error message too. Excellent. How are things here? Do you have an error message or something? Also good. No error messages? Min? Great. So let's see. ID, what's the message here? Let's see. Okay. Oh, this is lowercase o. This is lowercase o. And then this must be a code or semicolon, the colon, not the one. So you can do one thing. No, this one keep. There we go. So this means, we take a matrix, and this is the first row of the matrix, and then this means we take all columns. Now it works. Excellent. Okay. So we have the inflation data. Now we can check that data, right? So you can just type it into the command window, infl sim, and then when you hit enter, this will give you, the time series for inflation for this 1,000 periods. Okay? That's what this is. Now, okay, so you can, and now the next task is, according to our task list, we want to plot that inflation time series. How do you plot stuff? Tell me. We learned this earlier today. What are the commands to plot? Plot, right? What's that? A plot, right? Exactly. So what, be careful, always open an empty figure is my advice. Because if you just write in plot, then Dynere is going to, or MATLAB is going to plot this in any figure that's already open. So it's going to plot it somewhere. Open always an empty figure. And then we're going to write plot, open parenthesis, infl sim, close parenthesis. And then we could maybe add a title with parenthesis saying simulated data, no, inflation simulation. Okay. So you're just going to do, figure, you do plot, what the data you have extracted from there, and then you do the title, and and then you say inflation simulated model data. So the title is then just going to put a title on top of the figure, and for that you need to have the quotation mark here and the quotation mark there. Okay? That's what we need to have. Okay. Excellent. Now let's run this. If you rerun now your Dynair file, you should get a figure. And the proof of the pudding is you should get a figure like this that you have. Okay. You should get a figure like this. Who has that figure? Perfect. Dean? Juan? You working on it? Perfect. Two? Am I pronouncing your name correctly? Two? Perfect. Yeah. Me? All things coming.
Okay, so what's the...
I just...
no, sorry. Okay, I just spotted the mistake, I think.
I'm just
There we go.
missing-
Infil sim. No, it's this one, in line, exactly. Infil sim and then close parentheses.
Sorry.
You do the round close parentheses.
Is it
You can see.
close bracket?
There you go. So this
The end round there. And then the title.
Yeah.
Okay.
I just get
Yeah.
problem because I have the different.
Keyboard. Okay. There we go. Now we run it. Okay.
There we go. Excellent. So everybody has that. Perfect, right? So then when you look at that graph, right, this is the inflation time series, and the units are of course important. And so if you multiply this by 400, then this is being annualized. Okay? So one thing to do is when you do this, you can just take the data and you multiply, that comes out of your Dynair field, and you multiply this by 400. Then you can interpret the numbers that you are plotting in percent, in annual percent. So then this we'll say, look, inflation here, this is the steady state. It goes 2 to 4% above steady state and 2 to 4% below steady state, right? So that's the economic units that the model produces. So multiply this by 400. Okay. So let me then remind you, we want to do what is the task that we have to do in terms of our task number 2, right? So we essentially did a lot already, right? We simulated now the model for 1,000 quarters to monetary policy shocks only, and we've plotted the time series for inflation. Now we need to do it for the output gap. Okay? The next task is to redo this for the output gap, and then produce a scatter plot and compute the correlation. That's our task. Okay? Good. So let's do that. And let me know you guys tell me what I should do now in terms of the typing. Okay? How would I be able now to get to plot the output gap data? What are the steps I would need to do now?
Go to the angles here to see the output gap correspond to which column first.
Perfect. Right? So we want to, first we need to know what position is the output gap in this output matrix. And it is in which position? It is in position number 2. Exactly, right? It's the second entry, so it's the second line in this output matrix. So I'm just I'm a robot here, okay? And I'm not hooked up to artificial intelligence. You guys tell me what I'm supposed to type now, okay? So what am I supposed to type where? To plot the output gap data. Tell me. Guide my typing.
Output gap.
Output underscore simulate.
Yeah, like this?
400.
everything column?
everything.
Yeah.
And the figure,
Yep.
Exactly. So then here, extract output gap, right? And then here a figure, right? Then we go under here. You're gonna do a new figure? Is that what you want, or what do you wanna? How do you want to do it?
can we do the figure and then the subplot?
Yes, we can. Absolutely. You tell me how.
So figure then just now we got the comment for the subplot, right? And
Yeah.
just, sorry, I'm not familiar with
Yeah,
this.
good. No, that's why we're here. We're here that you're supposed to get out of your comfort zone and you learn something new. That's perfect. Now this is exactly so. We need to have the command for the subplot. So subplot. What was the syntax there? Dean.
2,
Well, go ahead.
2, 3, 2.
2, 3, 1.
I see. 2, 3,
Yeah.
1. Okay. So what will this produce? Right. This will produce a figure with a subplot with how many rows
2.
and how many columns? Exactly. Right? So then we can have 6 subplots, and that's going to get 6 subplots. But we only want 2 subplots, right?
So 2 should be
2.
2 and 0, and then you get the first one.
First one, exactly. Now, but we want, like, first what you need to know is you need to know what you want to plot where. And one thing I would suppose is we could have the inflation rate plotted here, and the output gap plotted there.
So 2, 1, 1.
2, 1, 1 is a good try, but in MATLAB, the rows come first and then the columns.
Oh,
So it's going to be 1 row and 2 columns. That's how MATLAB thinks. Okay. So to have that, it's we have 1 row with subplots, and then we have 2 columns, in this thing. That's the idea. Okay. So it's 1, 2. MATLAB has first the row and then the column. And then the first is inflation. Perfect. And now, if you are, let's run this, and there's maybe one correction. I would do 100 here. Okay, just do 100 instead of 400, because we want to express the inflation rate in annualized percent. Okay, so this is quarterly data, and by multiplying by 100, you get to a percent, and by 4, you are annualizing quarterly data, quarterly expressions into annualized expressions. The output gap is typically kept in percent only, not in annualized percent. Okay? Inflation rates, interest rates are annualized by multiplying by 4 or 400, and objects like output or the output gap are typically only percentized and not annualized. Good. So now let's run this code. Okay, let's rerun the linear code, and then we all should get a figure that has the inflation rate in. There we go. Right, and this is exactly the idea. Dean and Min and everybody else was thinking about this. Right, the subplot. There's 1 row with figures and with subplots, and then there's going to be 2 columns. Column number 1, and there's going to be column number 2. Great. So next we're going to plot. Then the output gap. So what shall I type now for the output gap?
The
X.
plot,
Yeah.
X underscore C.
Okay. Plot x underscore sim. Yeah. Yes. Good.
Then title.
Yeah.
Output simulated model data.
Yes. Output simulated. Output gap. Important gap. Right. Simulated model data. There we go. Excellent. Now when I'm going to run this code, something interesting is going to happen, but let's try.
Do we need to put the subplot?
Exactly, right? Because it's going to plot it otherwise on, what's going to happen is you're going to plot this, and then MATLAB overwrites this plot with this. Okay? And we of course don't want that. So this has to be subplot, and now
1, 2, 2.
exactly, perfect. Okay. So now we run this object, and that's going to give us a boom. This the two time series for the output gap and for inflation. Okay? Wonderful. So maybe you want to finish this on your codes. Okay?
1, 2, 2, X, 0.
And let me know once everybody's done with getting these figures on your computers. Right? Getting those figures on your computers. Once you have that, let me know, please. Are you making progress on the computations, or are you? Yes. Oh, great, fantastic, very good. So who needs help with producing this plot? Does everybody has this plot? One, Lee, me. Do you get that plot? Two?
I only did one.
You only get one? Okay, good. Let's take a look. Good. Show me your code, please. No, actually, what's going on? Can you go to MATLAB? You're looking at an old plot. Type in close all. Type in close all. And then you run again the code. Then you're looking at an old code, an old file. Okay, good. Everybody got it? Perfect. Good, good. So let's proceed. And then what is the next task? The next task is to produce the scatter plot, right? To produce a scatter plot between inflation and the output gap. Okay? So how can you do that in Dyneer? Or in MATLAB, and this is MATLAB coding. How do we produce a scatter plot? Okay, the code for that is, you're going to open up a new figure, and that produces the scatter plot, and the command for that is very simple. You're just going to do scatter, open parentheses, and then you have the x data, which is going to be our output gap, x sim, and then comma, the y data, which is going to be the inflation data, right? Infl sim. That is the scatter plot. That's all. So this produces the scatter plot. Okay? That's it. And if you are done with it, then we could run it together. So you do the plot, if you do the MATLAB stuff. Oh, wait. Go. So the plot that you should have at the end should be looking like figure 13 on my screen. Where you can have, where, do you have that? Everybody got that? How about you? You can tell me? Perfect. Oh, perfect. Then great. Caught up. So what was the thing? Why didn't it work before?
I don't know,
But now it works. Okay.
Before I don't know.
Okay, great. Okay, does this look like it's familiar to you guys? We can put on labels. Let's put a little bit of a label here. So we could put like an X label, which is the output gap, and then we're going to put in a Y label, which is going to be inflation. Okay. Then you rerun your code. There we go. Right? So that's we only put the X label puts this little X label here, and the Y label puts this little Y label there. Does this look familiar to you guys? Can you remember this? I mean, this is exactly what we had in our classes in the slide deck with the cost push shocks, right? So this was in lecture number 3. Right? This was the lecture number 3 with the the model with the cost push shocks. This was exactly this. Now here we simulated it to the technology shocks, right? Those two plots. But that scatter plot here on the right hand side, it's exactly that. So that's how you produce that data, or how that values are. Now, the last but not least, folks, right? The one remaining task on the task list was we want to compute the correlation now between output and inflation. Right? And there's a lot of ways of doing this, right? One is to just type in, let's see, to type in core. I hope that works. Let me just check that in first. Infil sim, comma, x sim. No. There we go. So the command to compute the correlation, pi x, we're just going to compute a number for the correlation between pi and x, and the command for that in MATLAB is core, that produces the correlation. Now we need to be a little careful. Inflation is a line vector, right? Or is a row vector. But the correlation wants to have it as a column vector. And so that's why we're going to stick in infil sim, and the apostrophe here turns the row vector into a column vector. It transposes the data. Okay? It just takes this infil sim row vector and turns it into a column vector. Okay, and then you're going to do x sim prime. That produces the that produces also a column vector for the output gap, and that gives us the correlation. And if you then run the file, you're going to get the output there, and you see it's 1. Correlation between output and inflation is exactly 1. Isn't that beautiful? I mean, I don't know. Okay. Does everybody have that? Yeah. Now, let me show you, that's going to be the last thing before we move on to the next task. That correlation of 1, Dynea also gives you that. Okay? Dynea produces that number for you. Okay? And that is like when you are going up here into the Dynea output, right? You want to look for the place where Dynea gives you the correlation table. Right? Dynea gives you that correlation table. And the way to read this is, it provides you with what's the correlation between the 8 model variables that you have. Okay? So that first entry is the correlation of inflation with itself. Now that's boring, that's 1. But the entry in the 1.2 is the correlation between inflation and the output gap. That's exactly that number 1. Now there's some NaNs here, and that has to do with it that we set the variance of the technology shock to 0. So that's why this thing doesn't move, and so there's of course no data for that. So Dynea gives you that correlation. Beautiful, beautiful. So what is the next task that we want to do? And I think that's going to be our last coding exercise then on this standard New Keynesian model, which is which goes as follows. When we covered this slide deck, right, on the cost push shocks, we learned that in the data we get that 0 correlation. While in the model, counterfactually, we have that unit correlation. And then we learned that, well, the way the literature deals with this, we're going to put in that cost push shock. Okay. And that's going to be helpful because that cost push shock is going to produce, first of all, impulse responses where output and inflation go in opposite directions. That's the first thing. And it's producing this negative correlation between output and inflation. And then if we put all the shocks together, right, we're going to get that dot plot here. So the task is, the next coding task is to extend the nk.mod model to put in that additional shock into the model. So that will be the next task. we want to take our code and we want to extend it in a way that we want to put in this AT shock into the Phillips curve, and we want to put in this autoregressive coefficient shock here for the cost push shock. And then we want to simulate the model and so forth, subject to that. That will be the next task. So let me write this down as, and that's going to be our last task, possibly for this week. Let's see. Here. There. Okay, so task number 3. Task number 3 is to include the cost push shock, the cost push shock into the mod file. Okay, so we want to include that cost push shock into our mod file. That's the first task. And then the second task is to study the impulse responses, simulate and produce scatter plots, and assess the correlation. Okay, so that's basically the task that we do. So then study impulse responses, scatter plots, and correlations. And then compare to the data. Okay, are you ready? So again, I'm going to be the stupid robot. You are telling me what I have to do. Okay? So let's continue in our nkLifeCoding.mod file. Let me go to the very top, and I want to hear from you now. How would you approach the problem of including this cost push shock into this code? Tell me.
There's 2 parts. If we model the cost push shock, also follow the AR1 process.
Mm-hmm.
Then the first part is the endogenous shock. You have 1 part for the cost push shock,
Mm-hmm.
but then the exogenous part, right?
Okay.
We supposed need to declare
Yes.
the epsilon for the cost push shock.
Does somebody want to add something, or is everybody agreeing with that? So the basic bottom line is, you said we need to define the variable first, right? As an endogenous and an exogenous. If we model this as an AR1, and that's exactly what we want. We want to have an AR1 process for A. So tell me, where am I supposed to write what? You guys tell me. Guide my writing. Where should I write something?
So don't
Yeah. Tell me a line that I should edit or add or.
Line 21.
Line 21, okay. Okay, line 21, and then what am I supposed to write here?
Apps.
Dean, you wanna? Go ahead, Dean. Apps.
Apps, I don't know what's the symbol for the Cosmos soft.
Oh, it was A. We always used the A head, right? In the slides, we used the letter A for the cost push shock, right? In the model equations. Let's see, right? We use this letter A head or A, right? That's the syntax or the.
We have apps
So we want to write apps A. Perfect. Okay, so this is now going to be the innovation to the cost push shock. Exactly. Perfect. What else?
I think the line 40 need to change the initialization value.
Line 14.
40.
Okay, I would suggest we keep editing the top part of this a little more.
Okay. Then
Because, I mean, this was great, right? So, remember what we did, what we want, folks.
endogenous variable.
Yes.
One for the
Right?
shock.
Because we have defined now this, right, as an exogenous shock, but we need to define this as well as an endogenous variable. Spot on, folks. Okay. So, and I should do that where?
Line.
Exactly. So Lynn says in line 15 we should write in A head, right? And that's going to be our cost push shock. Here we go. Right? That is our cost push shock. Great. I would generally advise you when you are doing what we are doing, like extending codes by sharks or features, go from top to bottom and try to jump as little as possible back and forth. Go simply line by line and think, should I change something here or there, and so forth. So now you tell me, where should I go next? Where should I go next? Can you say it again? Additional parameters. Tell me the line that you would like to add.
Sig A. No.
Row 8? Oh. So wait, what? Yeah. Tell me the line. Where? I'm your
28.
38.
28 to
28.
to get the payment.
Oh right.
The sig A. One more parameter.
Yeah. Okay. So here you want to add. We need to add two things. And Lynn said row A, right? So we have a new parameter, row A, which is the autocorrelation, right, of the autoregressive shock. And then what else? Possibly by symmetry. Let's stare at the equation. So we are working on by putting in this this A here, right? We did this. There are two parameters, right? There is this row A parameter. Exactly, right? There is this row parameter, but then this also has the variance parameter.
Sig A.
Sig A, precisely. Right? So let's go there. And so we need to write sig A. Those are going to be our two new parameters, and you see it's very symmetric. We have sig Z and rho Z. We have rho nu and sig nu. So that's symmetric. Okay. So then next, what else should I do? It's great that you're doing my work.
Sig A.
Yes. Initialize the variables, right? That's right. So we need to initialize them. And in the slides I use the same persistence as for all other shocks. So we write rho A is equal to 0.5, right? 0.5. So that is the standard deviation of the cost push shock. What am I saying here? It's the AR1 of the cost push, right? And then the sig A, that is 0.01, which is the, exactly, that's the standard deviation of the cost push. I want to do one change, folks, with you, because I want us to focus on this shock alone. So that's why I would, for now, suggest that we set this to 0 as well. Right? So we are setting the variance of the technology shock to 0 as well as the variance of the monetary policy shock. Sorry, Lynn? Yeah?
I mean, we assign 0 to all the shock, size shock.
That's right. Right? And it's like but the idea is basically that I want for now only later on study the effects of this cost push shock. And then at the final step we are bringing in all the shocks to see whether we can get that dot cloud. That's the idea. Okay. So, what's next up? What is the next step?
The function.
The equation. Exactly, Ivy. Right? Now it's time to go to the equation. So tell me the line where you would like to have the equation type.
You can see
We adjust the
Need to change the IS curve.
VT? One at a time. Sorry, you don't have to tell me. So what do we do? We need to. So Min had a good idea because I told you please try to go through this line by line and see where are the changes going to come in. And Min said something. We need to change an equation. Okay, and the idea that Min has is maybe going here. Okay. So what we did is we have put in the parameters so far, right? And now is the time to see where does this A shock show up in the equations.
Philip curve.
And so which equation do we need to change? The Phillips curve, right? That's what we need to do. Okay? So there we go, and we are hunting for the Phillips curve. And now you tell me, what should I write here?
Plus
Plus
A hat.
A hat, exactly one, right? A hat, right? So the idea now, make sure you're using exactly the same letter here as you are using when you define this in line 15. That is very crucial. Great, folks. Okay, so what else? What is the next thing? What else?
Function.
Need to declare the shock,
Yeah.
costal shock.
Yeah.
So you need to declare the AR1 process.
Yes, that's right. Absolutely. And maybe the way I write my code is I'm trying to keep all my exogenous processes next to each other. So I would suggest we are writing this in line 72, and this is going to be the cost push shock. Right? And now you tell me, how do we write this equation?
A hat is just now.
Multiply with rho hat minus 1.
Exactly, it's A hat minus 1, right? And how do I continue?
Epsilon.
Minus or plus?
Thus is
The minus is special because of the multiplicity shock we want to flip, but here plus and then eps A, right? Exactly, eps A. And then we do a semicolon. I'm sorry. Can we leave the equation like this? Is this correct?
You need to close.
Exactly. That's like never go to bed without checking your codes whether they have a semicolon there. It's like the thing to do before you close your day. You know, you make sure you have all the semicolon. Good. That's it. Perfect. What else do we need to do? Variances. Great, Dean. Right. So now let's browse further a little down here. Wait a second. We need to maybe also. The variances are spot on, right? Dean, you're right. Down here, but like going line by line, shouldn't we also work on the init val? So the init val are the initial guesses for the steady state. In general, these must be as many as variables we have defined in the endogenous block. So what shall I write here, perhaps?
A hat is equal to 0.
Exactly. A hat is equal to 0. If you forget about this, it's not so much of a problem because by default, if Diner doesn't find anything here, it assumes 0. But it's of course very dangerous. If you have a model where the steady state is not 0, then it's the wrong number. And now we come to Dean. Dean said, the variance of the shocks, right? And that's exactly what we need to have. Now we need to, include also the variance of the cost push shock. And can you tell me what I should write here?
From
Exactly. Semicolon, right? So the idea is that, sig is the standard deviation, you have to square it to turn it into a variance. So var here means variance. So that's it. That's it. That's all the changes. So define the A process, exogenous, endogenous variables. Put in the extra parameters. Adjust the Phillips curve and define the AR1 process for A. And last but not least, specify the variance of the shocks. That's it. That's how now we have extended this model to include, cost push shocks. Now we run this file. The rest, right, is very general, right? We're simulating the model. We want to extract still inflation in the output gap from it. But this is all general, and this is not tied to any specific shock, right? So when we now simulate the model in this simulation matrix, we now have the simulated data when the A shock is used only, because the other two shocks are switched off. And so then we do the scatter, and then we do the correlation. Okay. So let's run this code. Let's see what happens. So So let's do Diner, run this code, and what we should get is we should get 3 pictures. And let's make sure that we get those 3 pictures first, and then we discuss what these 3 pictures mean. And I want to make sure that everybody has those pictures before we discuss them. So,
Maybe the only
do I get it?
the arrow.
Okay. So let's see. We have a little error message. I take it. So let's see. Oh, okay. Go into the mod file. Can we take a look at the mod file, please? Can you scroll up a bit? And then let's see. Perhaps A is in there. There is in there. Yeah, I think I know where this comes, but can you scroll a little bit?
Where?
Slowly down, but slowly, please. So row A, CA, slowly down. Stop, please. Good. No, there. This must be row A. That N is there's one N too much. Exactly. Now slowly down. So this is great. Further down, please. More down. Stop, please. Row A. That looks great. Eps A. Good. Further down, please. Down. I think that could be it. Good. Now we could try rerun it. It could have been that just that parameter.
But the last I have the problem with correlation here in the last task. Task 2 already have the problem with this. So
I see. So let's see what we have here. Okay, now first it solves. That's good. And it produces a lot of stuff. X label. Ah, there. X label. Can you switch the L with the E? Label. To delete the L and put exactly. And also the Y label, the same there.
just
The same
stop
there.
here.
Label, exactly. And if you run this now.
Okay. Just stop.
I think that looks great. Fantastic one. Great. Great, Dean. Okay, let me know when you need help. Yeah. I see 2 has it. How about Ivy has it? Perfect. Great. Oh, you're ahead of us. Great. Good.
Because I forgot to decide.
To set this to 0, right? Perfect. This is great. So let's see. We'll. Okay, take your time. Perfect. So let's wait another minute, and then once Min.
You done? You have it? Excellent. Perfect. So we all have these 3 plots here, and these 3 plots are, similar to those that we have on our slides. First of all, let's discuss this, right? These are the impulse responses of the model, right, to this cost push shock. And we've discussed this on Wednesday. So we have this jump in A, and then it comes back autocorrelatively, to baseline. And what does it produce? Well, as we learned on Wednesday, when A goes up, firms increase their prices, right? Marginal costs go up. firms increase their prices, so we see higher inflation. And as a result, when firms post higher prices, demand is going to crumble. And then we see, X is going to fall. Which is exactly that, opposite side, movement in the, where did this go? No, it's gone. I know, sorry. Okay? Which is exactly this opposite movement of inflation and the output gap. We had this on Wednesday. The plot was kind of coded, not coded, the plot looked a little different, but it's exactly this plot, right? Where the output gap and inflation move in different directions. Okay. Wonderful. Okay, so that's the first thing to have. Then, our code produces this correlation pattern. This long simulation. Now, this is now the simulation with these cost push shocks only, right? For 1,000 periods. Okay, and you see the variation. And then the third plot that we put together is this scatter plot. And there you see now is exactly the opposite direction, right? With monetary policy shocks, this went this way, and now with cost push shocks, it's this negative correlation. And then the data, or looking this in MATLAB, right? We see that the correlation is now -1. And you can find that correlation also in the MATLAB output if you're searching for the correlation matrix, the matrix of correlations. Now you see the correlation of inflation with the output gap is -1. Beautiful. Okay. Now the last part of this task is, and then we are approaching the end of today, is the following. We were, the idea is, I told you that when you have all the shocks on, then this looks more like a shotgun blast than in the data, okay, with a zero correlation. So how could we now try to get this going? Okay, so how would you change the code in order to think about the data, the comparison of the model against the data? How would you do that? Turn all the shocks on, right? Exactly. Right? So how do we turn all the shocks on? Well, we go to our parameters, right? And then we have, so far we have, commented out this and that shock, right? So we have set the variances to 0 for the technology shock and for the demand, for the monetary policy shock. So let's bring in the original numbers here, 1% there, and 1% there, okay? And hit save. And now we have all the 3 shocks active. And now we rerun the code. And let's see what happens. And so we run the code, so we get like 3 impulse responses, and we get this long simulation. And there you can already see now with the 3 shocks, it's not a straight line any longer. It's not a straight line. It's not a cloud yet, but it's not -1. The correlation is like -0.68. So it's not 0, it's not 1, but it's getting there. And just to make sure, right? Let's look at this correlation table. Now you see the correlation table is exactly at -68. Now, how could we try to get that dot cloud? What do you think? I mean, the idea is, I gave you, in the classes, I gave you that, there is a version of this model that can deliver this dot cloud. Right? But we see still this negative correlation that is, is -0.7. Oh, Anne, is there a problem?
No, I don't know about the data, but.
Let's see, what do you got here? Oh, you have a positive number. I see. Can I see your parameters? Can you go to the parameters there, and then slowly? It's interesting. Yeah, you have a different.
But I don't know. I did not fix any. So.
Yeah. Can you scroll down and show me the AR1 processes? You scroll down slowly. Yeah, that's interesting.
Also the minus and
Yeah,
plus.
So good. Oh, I see what it is. Can you go to the shock statement? I think you must have, where we write the shocks down there, where we say shocks end further down. A little more. There. Oh, this looks all good. Yeah, I don't know exactly why. Let's maybe do this after class, or we can compare. I'm going to post my my files. I just want to, because this is already great.
Yeah,
This looks.
that's right.
This is where I want to get to.
Okay. So we want to get to this, right? Now, but we aren't there yet. Can somebody help me understanding what does it take to produce this cloud, from this code, right? So we have instead of -1, or instead of 0, we have a -0.7 correlation. How would you think about what's the reason why we have -0.7 and not 0? Think about this. So we have 3 shocks in this model, operative, right?
Last time the -4 only 3 shock. I don't know if it impact because normally we for AR1 of the shock
Yeah.
function
Uh-huh.
we plus the F's, but I don't know why it changed.
So you're on something. You're onto something there. I think the key is the following. It's a parameterization issue, right? Because if we only have monetary policy shocks or technology shocks, we're on this blue line. If we only have cost push shocks, we're going to be on this red line. And it's the combination of all these shocks that produce the dot. So in other words, if one of these shocks is dominant, if most of these shocks, if inflation is driven mostly by this,
Yeah.
it's going to produce a correlation pattern that looks more like the red line rather than the dot. So the long story short is, folks, the thing that you need to do is you need to look at the variance of decomposition. So we're going to go back to Danier, and we're going to go into the variance decomposition plot for inflation. Okay. So there is the command window output, and what you see there is this is the decomposition. So what is the decomposition by what is inflation driven by? And this number 1.7 says the inflation variability is driven, 1.7% of it is only coming from technology shocks. 6.6% is coming from monetary policy shock. But 86% of the variance of inflation is driven by the markup shock. And that's why, the markup shock is the most important shock that is driving inflation. Right? So this shock produces most of the variation of inflation. And given that we know this markup shock has this negative correlation, right? If most of the dynamics in the economy are driven by this shock, that correlation is going to show up more prominently. That's the key.
Yeah.
Okay. So then, in other words, one way to think about this is now we have to dial back a little bit on the variance of the cost push shock. We have to reduce the variance of the cost push shock a little bit, so that the cost push shock isn't so dominant. That's one way to think about this. Okay, and the way we do this is you go to your code, and then you're going to try to reduce the variance of the cost push shock. So, like for instance, instead of having sigma be equal to 0.01, you're going to have 0.05. So you cut the variance of the cost push shock by half, and then you rerun this code. And then you get the impulse responses and so forth, and then at some point you're going to get that plot, and you see that it's going to start looking more like a dot plot. No? Because you see the empirical correlation is now only 0.16 negative. And if we go to the variance decomposition, right? If we go to the variance decomposition, there we go. Now you see this is less important. This was 80 something before, now it's only 60 something. And so you can now think more of maybe reducing this even further. So you make this 0.33, right? You're reducing that variance even further, and then you're running this, and at some point you're going to get closer and closer to what you observe in the data. Okay, now you see it's slightly positive, so I reduced it by too much. Now the other two shocks take over, right? Now the technology shock and the monetary policy shock become too important because we have a positive correlation. So at the end of the day, something like 0.4 or so will actually going to do the trick here, and we're going to produce something that is exactly that dot, and you see it's a correlation of 0.05, and in the data we have 0.03. That's the basic law. Fantastic, folks. Any questions? Any questions that you guys may have? So this brings us to the end of this week. I mean, we've been here since Monday, and I think we've accomplished something in this week. I think you all have a great understanding of the basic New Keynesian model and the inner workings of that. We have learned that to make that model align with the data, we require not only monetary policy and technology shocks, but we also require cost push shocks. So that was the first part of this week. Second, we started with the macro climate model of Saruk, Smets, and Wouters, and we have derived everything theoretically. We understand that the model qualitatively is able to help us thinking about climate inflation and greenflation. And we understood how to put in the model features into that model, and we understand the model theoretically. And then, last but not least, today was an entire day on this. We are now also able to have familiarized ourselves in working with Dynair and working with mod files and extracting information and manipulating code and extending code. And I think we've come pretty far today with this. Okay? I think you should all be now in a position to understand where all the slide material from Monday, Tuesday, Wednesday comes from. Now, what's ahead of us is next week is we're going to be doing two things next week. On Monday, we will be running the computer codes for the macro climate model. I mean, the idea was to do this today, but I think what we did today was very good. That we took enough time today so that you're going to be much more efficient in running this code next week. You will be we will make faster progress next week with all the things we have learned today on MATLAB and Dynair. Okay? So on Monday we will run code from this model. In particular, if you go to Moodle, we will be running this node trends code. Okay? And we will be working with that a little bit. We will be looking how shocks are specified. We will learn about the solution technique and so forth. And then for the remainder of Monday, we will be finishing the slide deck, leg 04 climate. Okay? So there's a couple of slides left. In fact, I think 30 or so slides we have left. So that will take us through the analysis. And I will put a big emphasis on Monday on understanding things like these, like understanding the simulation results, understanding the economics. That's what we're going to put a lot of weight on Monday. My hope is, but without racing, that we will be able to finish this on Monday. It's going to be a busy day. Doing the computer codes of the macro climate model and doing this, it's going to be challenging. So given that we've been slow today, it may be that we have to extend this into Tuesday morning. But by Tuesday, second lecture, we're going to do the next topic. We're going to start the next topic by Tuesday, in the second lecture. And then we will have enough time to also cover that topic next week as well. Are there any questions? So this was a great week. I hope you're going to have a great weekend. If you have some spare time that you want to use, maybe and anticipate some of the material, you could start reading. You don't need to, but you could start reading the paper, right? In particular, you could start reading the Saruk paper. The Bianchi Faccini Losi paper. Although there is this dedicated Monday afternoon self-study session, right? So it's enough to read it then. But if you're saying for some reason you're going to be busy on Monday afternoon and you want to do this rather tomorrow or on Sunday, the task that I will give you for the Monday afternoon study session is this one here, to read this. Are there any questions? You've studied hard, I think you deserve a weekend, so you guys have a great weekend, and you enjoy the weekend, and you find some rest, and then I'm looking forward to seeing you on Monday morning at 9:15. Thank you very much for this week. Thank you. Thank you. All right, great. I'm gonna post my live coding file onto Moodle. You guys all have that stuff, but just in case, I'm gonna post that on Moodle as well.